Good afternoon, this is Schweitzer. We're going to do a small little video here on launching and an energy version where it is versus kinematic expressions. Now, a few things you might want to be aware here is that just as we start this problem, you might want to pause it and then we're ready to go. But I'll tell you when to pause. But just so you're aware that we're doing a launch. We're going to launch this thing straight up, reach a maximum height, and have it fall back down. We've done a bunch of problems here where things, fell off cliffs. You can do that way too. Launch it straight up and down, and we also could do straight up and off a cliff. What we have not done yet is simply like launching at an angle. That will be next chapter. We generally call that projectile motion. So either way, we're going to solve this thing with energy. So if you want to pause the video right now, you can. Alright, a missile leaves the surface at 240 meters per second. What's its maximum height that it will accomplish? Well, we have at the bottom of our little picture here, we have a rocket that is at 240 meters per second. The kinetic energy and plus the potential energy, now it's on the ground so it has zero potential energy, equals at the maximum height. Okay, what is this height? At that point, the kinetic energy is all gone, and all we have left is potential energy. So the kinetic energy is 1/2 mv squared equals mass times height times gravity. Because I have mass on both sides, I can cancel it. I'll get 1/2 velocity squared equals height times gravity. Solving for height, we have 1/2 velocity squared over the gravity equals height. Math-wise, that's 0.5 times 240 divided by gravity, which is 9.8, equals the height. Alright, what is the height here? 0.5 times 240 divided by, now this guy is squared here, don't want to forget that. So it's going to be 240 squared is 57,600 times 0.5 divided by 9.8 equals, I got 2,938 meters high. Alright, now let's say, okay, what is the what is the speed above the surface 100 meters? Okay, and if you haven't solved that one yet, then go ahead and pause the video for a moment. Alright, so now we draw a picture of this thing. We got our rocket on the ground, and it goes to a maximum height of 2,938 meters. So what would it be at 100 meters? Alright, so at this point it still has lots of kinetic energy, but lost some to potential. So we have only have kinetic energy before, and we have ending with some potential energy and some kinetic energy. This is at 100 meters. Okay, so the kinetic energy is 1/2 mass velocity squared equals mass times height times gravity plus 1/2 mass velocity squared. Masses can cancel out of all of these. 1/2 velocity squared equals height times gravity plus 1/2 velocity squared. Alright, and this point is going to be, I want to solve for this variable right here. That's my ending velocity. 1/2 times 240 squared equals height, 100 times 9.8. That's one value, plus 1/2 v squared. So 240 squared times 0.5 equals, this is going to be 28,800 equals 9,800 or 980, whichever seems best, plus we got 1/2 v squared. Alright, so at this point subtract off the 980. We get 19,000, close. $26,900 equals, and then we got 1/2 v squared, so we're going to divide this thing by 0.5 equals 53,000, and then we'll square root the answer, and we get 200. The velocity equals 231 meters per second. Of course, it started at 240, so it has not slowed down too much. It's got a long ways to go. Alright, how would we solve these problems with our kinematic expressions? Again, we don't want to ever leave that alone. Alright, so let's go ahead and solve this problem right here. How high can we go? Well, we have the distance s equals xi plus vit plus 1/2 at squared, and vt equals at plus vi, and this is the velocity at that time. This is the distance at that time. So let's see what we got. We want to know how high we can go. So I'm looking to solve for the distance. Alright, so let's see what we got here. The distance t equals 0, that's xi, plus vi is 240, I don't have my time, plus 1/2, and then negative 9.8, and t squared. Now it's important, remember, to notice that over in these problems, gravity never was negative. Energy is not a vector, so it does not have a direction, it does not get a negative. Alright, now I have, in this case, we just get, this just becomes 4.9 t squared plus 240 t, and then plus, okay, 0 equals the distance, st, okay, we're missing two variables here, so this isn't going to work. How do I get my t? Well, the vt equals usually vi plus at. Okay, so vt is 0 because I'm going to go up and I'm going to stop at the very peak. V equals 0 and then come back down. So that's the velocity at the peak. Initial velocity is 240, negative 9.8, and solving for t here. Once I have this t, I can plug it back into that formula. So in this case, we'd have negative 240 equals, alright, divide by, let's give myself a little room so you can see. Alright, divide by negative 9.8, and this is going to give me a positive value t, which is great because we don't want negative time. 240 divided by 9.8, and I get 24 seconds. It's quite a long time to be in there. Alright, so at this time we got 24 seconds into our distance formula. I'm going to just redo that here. Value equals 0 plus 240, and that's going to be 24 seconds, plus, okay, 49 times 24 squared. Okay, I'm getting 28,224. Okay, and this should be a negative value with the gravity being negative. We got a negative 49 here, so this should be a negative 49 right there, 4.9. So make sure I get my math right here. Don't want to lead you astray. Alright, so we got, plugging it into that guy would be 1/2 times, lost a few things there. Eraser kind of went nuts. Negative 4.9 times 24 squared. Alright, and let's do that one more time. 24 squared equals, this is 576 times negative 4.9 equals, alright, and we got ourselves a value here of negative 2822. This guy here is 240 times 24 equals 5,760. Alright, and subtract that from the previous answer. And we get around 2938. Oh, exactly what we got the last time. You could get some differences in rounding, but it looks like we're right on. Alright, and finally it says, alright, what will be my speed at 100 meters? Alright, so distance equals xi plus vit plus 1/2 at squared, and velocity at some times t equals a, let's go with velocity initial plus at. Okay, so I'm looking for the velocity at 100 meters. So in this case, I got the work here wise. I got start plugging the values, and this is what I want. It's going to be 240 plus, and then we're going to, in this case, negative 9.8 times t. Okay, well again I don't have t, so I can't use this. I want to get t. Use the other formula. Okay, so this is going to be 100 meters plus equals 0 plus 240 t plus 1/2 negative 9.8 t squared. This is again negative 4.9 t squared. I have a positive 240 t, and then minus 100 equals 0. This looks like a pretty typical quadratic formula. Alright, and at this point, we want to know how long it takes to get this thing. If you plug this thing into your quad form, it's kind of unique. You're going to find that this thing goes up, it comes to 0, and it comes back down. The math is pretty nice because it's giving me two values. It's giving me the value of 0.42 seconds, and it's giving me a value of 48 seconds, which is pretty cool because this thing is literally going to hit 100 meters twice. After 0.42 seconds, go all the way to the top, and then come all the way back down, and it'll hit again in 48 seconds. So at this point, this trip is a little bit more than 48 seconds total. Alright, so at this point I want to know my velocity at 100 meters. Now technically it would be the same. I'm going to take this first one for my trip. In this sense, I want to know, okay, how fast am I going at 0.42 seconds? Let's plug that 0.42 seconds into this guy right here. 0.42. times negative 9.8 equals, okay, 4.16. Negative plus the original 240 gives me, in this case, plugging that math into there, I get a 235 meters per second. And a little bit off for rounding on that guy. Hope that was helpful. Thank you very much.